A neon tester is designed for relatively low voltage circuits, typically 120 volts or less. If the circuit you tested was carrying a significantly higher voltage, such as 240 volts or more, it could overwhelm the neon tester's components and cause a spark, potentially damaging the tester. The neon tester's internal components, which are designed to illuminate at a specific voltage range, may break down when subjected to excessive voltage. This breakdown can create a short circuit within the tester, leading to the observed spark and potential damage. Additionally, the tester itself could have been faulty or damaged prior to use. Internal cracks, loose connections, or degradation of the insulating materials within the tester can compromise its ability to safely handle even the intended voltage range. These defects can create pathways for current leakage or arcing, resulting in a spark when the tester is introduced to a live circuit. For safety and accurate circuit testing, a voltmeter is recommended. A voltmeter is designed to measure a wide range of voltages without posing a risk to the user or the instrument itself. Before touching any wires, especially when the voltage is unknown, use a voltmeter to determine the voltage level present. Select an appropriate voltage range on a voltmeter that is higher than the expected voltage of the circuit being tested. Connect the voltmeter leads to the circuit in parallel, meaning one lead to each point where you want to measure the voltage difference. Observe the voltage reading on the voltmeter's display. If the voltage is within the expected range for a standard household circuit, such as 120 volts, you can proceed with further testing with caution. However, if the voltmeter indicates a higher voltage, such as 240 volts, it is crucial to exercise extreme caution and consult with a qualified electrician. Never assume the voltage level of a circuit without first verifying it with a reliable measuring instrument like a voltmeter. Before working on any electrical circuit, it is crucial to identify the circuit breaker or fuse that controls that circuit. Turn off the breaker or remove the fuse to de-energize the circuit. After de-energizing the circuit, use a voltmeter to verify that the circuit is indeed dead before touching any wires. This is a crucial safety step to prevent electric shock. Even after de-energizing a circuit, there may still be residual voltage present due to capacitance or other factors. Use a voltmeter to check for any voltage between the wires and ground to ensure that the circuit is completely safe to work on. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses, when working with electrical circuits. This will help protect you from electric shock and other potential hazards. When working on electrical circuits, always follow the National Electrical Code, or NEC, and any other applicable local codes. These codes provide detailed requirements for safe electrical installations and practices. If you are not comfortable working with electrical circuits, or if you are unsure about any aspect of the work, consult with a qualified electrician. It is always better to be safe than sorry when it comes to electricity. There are several types of voltmeters available, each with its own features and benefits. Analog voltmeters use a needle to indicate the voltage level on a scale. Digital voltmeters display the voltage level numerically on a screen. Auto-ranging voltmeters automatically select the appropriate voltage range for the measurement. Clamp-on voltmeters measure the voltage without requiring direct contact with the wires. When choosing a voltmeter, consider the voltage range, accuracy, resolution, and features that are important for your specific application. A voltmeter's accuracy refers to how close the measured value is to the actual voltage level. A voltmeter's resolution refers to the smallest voltage increment that the voltmeter can display. For general-purpose electrical work, a digital auto-ranging voltmeter with a voltage range of at least 600 volts and an accuracy of plus or minus 1% is a good choice. The NEC contains a wealth of information on safe electrical practices. Article 90 covers the purpose, scope, and organization of the code. Chapter 1 covers general requirements for electrical installations. Chapter 2 covers wiring methods and materials. Chapter 3 covers equipment for general use. Chapter 4 covers special occupancies. Chapter 5 covers special equipment. Chapter 6 covers special conditions. Chapter 7 covers communications systems. Chapter 8 covers outside wiring. It is essential to familiarize yourself with the relevant sections of the NEC before undertaking any electrical work. Different types of electrical testers exist, each designed for specific purposes. Continuity testers are used to verify that a circuit is complete and that there are no breaks in the wiring. GFCI testers are used to verify that ground fault circuit interrupters are functioning properly. Outlet testers are used to verify that electrical outlets are wired correctly. Wire tracers are used to identify specific wires within a bundle of wires. When using any electrical tester, always follow the manufacturer's instructions and safety precautions. If you encounter any unusual readings or unexpected results, stop immediately and consult with a qualified electrician. The NEC requires that all electrical work be performed in a safe and workmanlike manner. This includes using approved materials and equipment, following proper wiring methods, and ensuring that all connections are tight and secure. Electrical connections should be made inside of approved junction boxes or enclosures. The junction boxes or enclosures should be properly grounded to prevent electric shock. Wires should be properly supported and protected from physical damage. Cables should be secured with cable ties or clamps. Conduit should be properly supported and grounded. All electrical equipment should be installed in accordance with the manufacturer's instructions. When working on electrical circuits, it is important to be aware of the potential hazards. Electric shock can cause serious injury or death. Arc flash can cause severe burns. Electrical fires can cause significant property damage. To minimize the risk of electrical hazards, always follow safe work practices and use appropriate personal protective equipment. Never work on electrical circuits when you are tired or distracted. Never work on electrical circuits in wet or damp conditions. Never work on electrical circuits while wearing metal jewelry or clothing. Never use a metal ladder when working on electrical circuits. Never overload electrical circuits. Never tamper with or bypass safety devices. If you smell burning plastic or see smoke, turn off the power immediately and call the fire department. Electrical safety is everyone's responsibility. By following safe work practices and using appropriate personal protective equipment, you can help prevent electrical accidents and injuries. Always be aware of your surroundings and take precautions to protect yourself and others from electrical hazards. Regular electrical inspections can help identify potential problems before they become serious hazards. A qualified electrician can inspect your home's electrical system and identify any issues that need to be addressed. Electrical inspection should be performed at least every 3 to 5 years, or more often if you have any concerns. Electrical inspections can help identify problems such as loose connections, damaged wiring, overloaded circuits, and outdated equipment. Addressing these problems promptly can help prevent electrical fires, electric shock, and other hazards. When hiring an electrician, be sure to choose a qualified and licensed professional. Ask for references and check the electrician's credentials with the state licensing board. A qualified electrician will have the knowledge, skills, and experience to perform electrical work safely and correctly. The electrical system in a home is a complex and potentially dangerous system. It is important to treat electricity with respect and to follow safe work practices when working on electrical circuits. If you are not comfortable working with electrical circuits, consult with a qualified electrician. Remember, safety is always the top priority when working with electricity. It is always better to be safe than sorry. If you have any doubts about your ability to perform electrical work safely, consult with a qualified electrician. Electricity is a powerful force that can be both beneficial and dangerous. By understanding the risks and following safe work practices, you can help ensure that you and your family are protected from electrical hazards. Always be aware of the potential dangers of electricity and take precautions to protect yourself and others. When it comes to electrical safety, there is no room for complacency. Stay informed about the latest electrical safety standards and practices. Share your knowledge with others and help promote electrical safety in your community. Remember, electrical safety is everyone's responsibility. By working together, we can help prevent electrical accidents and injuries and create a safer environment for all. When testing circuits, be absolutely certain of your equipment and the circuit's voltage.